Good morning, students. Welcome back to the chemistry class. So in today's class we are going to start new chapter, that is chapter 9, carbon, and this is the last chapter of your semester 3. Okay, so let's start this chapter. So in this chapter basically we are going to learn about the carbon, that why carbon is so much important element, and what are the various compounds and what are the various forms of the carbon which are being found and what are their use. So this is what we are going to learn in this chapter, carbon. So let's start this chapter. So carbon is very important element. It has many uses. The food we eat has compounds of carbon. Okay, so the food we eat basically have compounds of carbon. Okay, then coal and hydrocarbons are widely used as fuels. So we know already about CNG, LPG, all these are carbon compounds. Okay, and there are various fuels in which carbon is used as the main element. Then carbon compounds are also used in medicines. Now there are various medicines in which carbon compounds are being used. Okay, and then the clothes we wear have compounds of carbon. Okay, so as you can see here, basically everything which we need in our day-to-day life have compounds of carbon. So this is how carbon is very important element, because it is the essential part of our day-to-day life, whether it is food, clothes, fuel or anything. Carbon is very important element in all those compounds. In the form of diamond, carbon is used as a gemstone. Okay, in the form of graphite, carbon finds a wide application in industry, and in the form of carbon nanotubes, it plays a great role in nanotechnology. So these are some of the forms of the carbon: diamonds, graphite, carbon nanotubes. Okay, and these are useful in one or the other way. So about diamonds, you already know it is a gemstone used for making jewelries. Okay, and diamond is the hardest thing known. Okay, then it is used in the form of graphite. Okay, in the form of graphite it is used, and it's very useful in industry. Okay, and then carbon nanotube is also one of the form of carbon which plays a great role in nanotechnology. Okay, so now next topic is occurrence. So in the free or in the combined state, carbon is widely distributed on Earth. So there are two states in which carbon is being found. One is free state and second is combined state. So let's see in what other form it is. In free state, first is coal. Coal is a decomposition product of plants buried millions of years ago due to some natural phenomena. So coal are not just being formed in one day. It takes millions of years for coals to form. And how they are being formed? By decomposition product. Okay, so plants or animals which are buried millions of years ago, so decomposition of those takes place, and what is being formed after decomposition is coal. So they are being under high pressure and slowly they decompose, and coal is being formed out of these. Okay, so that is why they are also known as fossil fuels. Okay, then plants contain carbon compounds and their buried remains were slowly converted into carbon. Okay, so this is how it is formed. Plants and animals contain what? Carbon compounds, and when they buried, what happens? They slowly convert into carbon, and this is how coal is being formed. The conversion of carbon compounds into carbon is called carbonization. Okay, so this process is known as carbonization, through which coal is being formed. Carbon compounds are being converted into carbon. Okay, so I think this is clear. Next, it is found in diamond and graphite, free state. Diamond and graphite are the crystalline form of carbon found in nature. Okay, so this is also one of the free state of the carbon. Okay, then graphite is most abundant than diamond. Okay, so graphite is found in plenty than diamond. Then in the combined state, so this is the next state in which carbon is formed. So in the combined state, it is found in the form of carbon dioxide. Air contains about 0.03% of carbon dioxide. So about this you already know that air contains one of the gas which is known as carbon dioxide, and carbon is being combined with oxygen in this carbon dioxide. So that is why it is a combined state. Then in living organisms, all living organisms have carbon compounds. Okay, whether it's plants or animals, every organism have what? Carbon compounds. The essential ingredients of food, carbohydrates, proteins, fats and vitamins are compounds of carbon. So we eat food from where? We derive food from where? We derive food from plants and animals, and all living organisms have carbon compound. Okay, so the essential ingredient will be what? Carbon compounds only, because we are getting all these things from plants and animals. Okay, and they have what? Carbon compounds. So that is why whatever food we eat are also contain what? Carbon compounds. Then third, minerals. So this is the third example in which carbon is found in the combined state. All carbonate minerals contain carbon. So here are some of the examples given of them. For example, limestone, calcite and marble are calcium carbonate. As you can see here, carbon is being combined with calcium and oxygen over here. So this is one of the combined form. Then dolomite is a mixed carbonates of magnesium and calcium. So this is one of the example of the compound in which carbon is found in the combined form. Okay, so likewise there are various other carbonates in which carbon is found in a combined state with other elements. Then next, natural gas and petroleum. So natural gas and petroleum contains mainly hydrocarbons. So hydrocarbons are those compounds which are made of hydrogen and carbon. So about this we have already seen in the previous chapters. Okay, so natural gas and petroleum contains mainly hydrocarbon, that is compounds which have only carbon and hydrogen. So as you can see here, carbon again is combined with the hydrogen. So this is also one of the combined state of the carbon. Okay, so natural gas is mainly what? Methane, CH4. So in this, carbon is being combined with 4 hydrogen. Okay, similarly petroleum is mixture of various hydrocarbons. Okay, so I think that combined state of carbon is clear. Okay, so now let's see. So here are the compounds which have carbon, common compounds which have carbon. So basically compounds are being divided into organic and inorganic. So here are some of the organic compound examples which have carbon in the combined form, and here are some of the inorganic compounds in which carbon is found in the combined form. So let's see some of the example of the organic compounds. As you can see here, hydrocarbons such as methane, ethane, butane, benzene. Okay, you can see here CH4 is this, then C2H6, C3H8 and then C6H6. So in all these examples you can see carbon is being combined with the hydrogen. Okay, then alcohols, methyl alcohol, CH3OH, ethyl alcohol, C2H5OH. So here also you can see carbon is being combined with hydrogen and oxygen. Then acids, you can see here acetic acid. Okay, acetic acid CH3COH. Okay, now again here carbon is being combined with hydrogen and oxygen. Then similarly glucose, very common example, C6H12O6. Here also carbon is found in the combined form with the hydrogen and oxygen. Then inorganic compounds, carbon dioxide, carbon monoxide, sodium carbonate, sodium bicarbonate, calcium carbonate, copper carbonate, calcium carbide. So okay, all these examples you can see here, these are examples of the inorganic compounds in which carbon is found in a combined state. Okay, so all the hydrogen carbonate or you can say bicarbonate and carbonates are carbon containing compounds which are inorganic compound. Okay, So now let us see the definition of organic and inorganic compounds. Okay, so all carbon containing compounds except carbon monoxide, carbon dioxide, carbonates and hydrogen carbonates are called organic compounds. Okay, so these are some of the exception which contains carbon but they are not considered as an organic compound. So except all these compounds, all other compounds in which carbon is there, they are organic compound. Then all non-carbon compounds along with carbon monoxide, carbon dioxide, carbonates and hydrogen carbonates are called inorganic. Now here all the non-carbon compounds will be inorganic, but these exceptions will also be included under inorganic compounds. Okay, so compounds are basically two types on the basis of carbon content. It is organic and inorganic compounds. So I think that this classification is clear. Now let us see the next important topic, that is allotropy. So allotropy topic is very important. So before studying this allotropy topic, let's see about the crystalline and amorphous solid first. Okay. So solids are divided into two classes, crystalline or true solids and amorphous solids or pseudo solids. Okay, so here two classes of solids are there, crystalline or you can say true solids, then amorphous or pseudo solids. So this is how solids are being classified. Now let us see the properties of crystalline solids and amorphous solids one by one. Okay. First of all, I would like to tell you the meaning of the pseudo-solids. So, pseudo-solids are those which have tendency of flow, okay, in a solid like a liquid. So, these are the solids but they have tendency to flow like a liquid. So, that is why they are known as pseudo-solids. Crystalline solids. Solids which have definite geometrical forms are called crystalline or true solids. Now they have the crystalline solids have what? Definite geometrical form. Okay, so definite geometry will be there. Okay, and they are known as crystalline or true solids. Common example you can take of rock salt, alum, sugar. Okay, so all these are crystalline solids because they have definite geometrical form. Okay, then next, the particles constituting a crystalline solids are arranged in an ordered manner in 3 dimensions. As you can see here in the diagram, the particles which are constituting crystalline solids are being arranged here. Okay, they are being arranged in an ordered manner in 3 dimensions. Okay, then when crystalline solids are being broken or cut with a sharp knife, we get pieces with sharp edge and plain face. So this is also one of the important property, that whenever we are cutting any crystalline solid, then whatever pieces which we are going to get, its edge will always be sharp and surface will be plain. Okay, plain faces will be there. So like this we are going to understand about the crystalline solids. Okay, and beside, crystalline solids have very sharp melting and boiling point. So this is also one of the important characteristic, and it is incompressible and rigid due to its ordered arrangement of particles. Okay, so particles which are constituting crystalline solid, as you can see here, is arranged in an ordered manner. So that is why they are almost incompressible and rigid in nature. Okay, so they will be hard to touch, crystalline solids. Okay, so next is amorphous solids. So amorphous solids are also known as pseudo solids. Solids which do not have definite geometrical forms are called amorphous solids. Okay, so they do not have any definite geometrical form. Example, gas carbon, then pitch, plastic. Okay, so what is this pitch? It is highly viscous liquid which appears solid. It is highly viscous liquid like coal tar, pitch. Okay, which is very highly viscous but appears to be solid. Then plastic, you already know. So all these comes under the category of amorphous solids. Then the particles constituting an amorphous solids are not arranged in an ordered manner. As you can see here in the figure, the particles which are constituting this amorphous solids are not arranged in ordered manner. They are being arranged in a disordered manner. Okay, so this is one of the difference you can see between the crystalline and amorphous solid. You can just see comparison in between the properties. Then when amorphous solids are broken or cut with a sharp knife, we get pieces with curved face. Now here we are not going to get pieces with sharp edge or plain faces. We are going to get pieces with curved face. Okay, so I think that difference between these two, crystalline solids and amorphous solids, is clear. Okay, so likewise for the crystalline solid, I have told that they are almost incompressible and rigid, but in the case of amorphous solids, these can be compressed and are soft in nature. Okay, and they do not have any sharp melting point or boiling point. So these are some of the difference also, okay, and properties also of the crystalline solids and amorphous solids. Okay, then what is this allotropy? So let us understand this, from where the term allotropy arrived. The phenomena of some elements existing in different form is called allotropy. Okay, so some of the elements, they exist in different forms. Okay, and this phenomena is known as allotropy. The term allotropy has been derived from Greek word allos, which means other, tropos means form. So two Greek words are being joined together to form one word, that is allotropy, which means other form. Okay, allos means other, tropos means form. Okay, the different forms of an element are known as allotropes. The phenomena is known as allotropy, and the different forms of those of that element is known as allotropes. Okay, the allotropes of an element are chemically the same but different from each other in structure, atomicity, or both. Okay, so chemical composition will be same. Chemically they will be same, but they will be different from each other in structure, atomicity, or both. Structure will be different. Atomicity means number of atoms present in the molecule of that particular element will be different. Okay, or both will be different. Then here are some of the elements which show allotropy: carbon, oxygen, phosphorus, and sulfur. Okay, so these are some of the elements which show allotropy. Okay, so very common example we can say is of carbon, about which we are reading right now. Diamond, graphite, fullerene, etc. are allotropes of carbon. Okay, so the carbon exists, or you can say carbon have maximum allotropes. It can exist in various forms. Okay, diamond, graphite, fullerene, etc. So dioxygen, as you can see, O2 and ozone, O3, are allotropes of oxygen. So you can see that carbons have various allotropes such as diamond, graphite, fullerene, and oxygen also have two allotropes, that is dioxygen, which is commonly known as oxygen, and then ozone, O3. And you can see here chemically they are same, but there is difference in between their atomicity. Okay, and then allotropes of an element differ in physical properties, and though they are chemically the same, they differ in some chemical properties too. Okay, so allotropes generally differ from each other in physical properties, but sometimes though they are chemically same, they can have some different chemical properties too. We can understand it with the help of these examples which are being given. So as you know that graphite and diamond are the form of carbon. Okay, they are the allotrope of the carbon, but they differ from each other in the physical property. Like, let's see, graphite is a good conductor of heat and electricity, whereas diamond is not. So this is one of the physical property in which the graphite and diamond are not same. Then in chemical property, how they are different? Graphite burns in air at 700 degrees Celsius. Okay, so this is degrees Celsius. Okay, at 700 degrees Celsius, whereas diamond does so at 900 degrees Celsius. So here, at what temperature graphite burns? 700 degrees Celsius, and diamond burns at 900 degrees Celsius. So this is one of the chemical property in which they are getting different. Okay. Next, ozone absorbs UV rays whereas oxygen does not. So this is one of the physical property in which they are getting differ. And then ozone is much stronger oxidizing agent than oxygen. So this is one of the chemical property in which they are getting differ. So by this we can conclude that allotropes of an element differ from each other in the physical properties, and in some of the chemical properties also they can differ from each other. So I think that allotropy concept is clear. Okay, and today whatever topics which we have studied is clear to you all. Okay, so just revise this chapter, okay, and go through it. In the next class we are going to study about the allotropes of carbon in detail. Okay, so that's all for today, students. Thank you.